proportions. 1:2, 4:8. This is one proportion. Another proportion is this. 1:2 is proportional to 2:2. If you see the ratio involved in both the proportion, here also it is 1:2, here also it is 1:2. The simple form of 4:8 is 1:2. Similarly, if you see the simplest form of 2:4 is 1. But both are proportions only and both of them are having 1:2. Do you see any pattern which makes this one different from that one?
Yeah.
Is it?
Can I say?
Yeah. Who was the other person other than Jaswal?
Me.
Okay. So yeah, anyone can go. You guys decide.
EP, I will go. So the thing that
Okay, everyone say at once.
1 plus 2, 2 plus 2 is 4.
You have to multiply this by into 4 and you have to multiply that by 2.
Okay, this is becoming a question. Yeah, let Ananki go first. Yeah, Ananki, tell me.
The common thing, the pattern in this is 1 plus 1 is 2, 2 plus 2 is 4, 4 plus 4 is 8.
Yeah, that's what is a ratio, right? That is what we are considering.
Basically, the first one is 1 into 4 and 2 into 4. The other one is 1 into 2 and 2 into 2.
Correct. But are you seeing any pattern here? Okay, let me just give one more example. Okay, let's say this
No, I'm not seeing a pattern.
is in the second class. Try to find something common in the second class. Okay, let's say.
Akka, just product.
The mean
Just a minute. 1:3 is
Acha, the product is the same.
21. The next one is 1:3 is proportional to 3:9. Now tell me what is similar in that class which is not similar in this class.
are the same. I've been shouting the same thing for ages.
What is it?
The means are the same.
I mean, I didn't hear it before. Yeah, correct. That's what we are looking at. So if you see, both of it is a proportion. This side is also a proportion. This side is also a proportion. But there is something special over there. Okay, a special character. And if you see the means, the two middle numbers in the proportion is called means. The one on the edges are called extremes. If you see the means are same in this case. The means are same in this case. So whenever there is a proportion where the means are same, then you would call that proportion as continuous proportion. Okay? So when would you call a proportion to be a continuous proportion? When the means are same. When the means are same. So in this case, we can actually compute a formula, right? Okay, let's say generally a proportion looks like this. Okay, let's say generally a proportion looks like this. A is to B is proportional to C is to B. But in case of a continuous proportion, okay, this is a proportion.
It's A is to B is to B is to C.
Correct. So in case of a continuous proportion, you would have A is to B is proportional to B is to C. And what is the condition we know?
B is the same.
No doubt. What do we know? Product of what is equal to product of what?
Product of extremes is equal to
Means are same.
Yeah.
AD and BB, AC and BB are the same.
Means
Can you shift the camera a little?
means is going to be equal to the product of extremes. So let's just write it down. Product of means is equal to product of extremes. Right. So what are the elements in B? B. What is B times B?
B square.
A times C.
B square. And what is A times C?
AC.
AC. So we have B square is equal to AC, which is a special condition in case of a continuous proportion. Now let's take an example. Okay, let's take an example. Let's say okay, if we know a particular proportion is a continuous proportion, okay? Let's take an example.
See, what is an index and index?
Index we've learned in last class, but that's not required for proportion, so let's just not concentrate on that right now.
I forgot.
So let's say we are given with a continued proportion. Okay, what is a continued proportion?
If we are doing in a slightly different way.
A continued proportion.
EP, your board is extremely blurry.
You can switch on the video and just try again here. The following is a continued proportion.
Yeah, are you recording, EP?
Yes, I am. Okay. So if we are given with a proportion, also it's given that it's continued proportion, say 1:dash is proportional to dash is to 9. Okay, so in the previous case where we are looking at only a proportion, we were asked to find only one particular number. In case of a continued proportion, we can actually find two different numbers, because they are actually the same. And what do we know in a continued proportion? B square is equal to AC. Then this is A, this is B, this is B, this is C. So we have B
So
square
B is.
equal to, wait, not yet. Let's just fix the point. So B square,
It's 3 and 3, right?
what did I just say?
No, wait.
One,
B square.
B square is 9.
What was I about to say?
What is a number whose square is 9?
3.
You should
3.
tell me. You are always messing up with the timing. So B is, the number over here is 3. So 1 is to 3, this is 3 is to 9. This is a solution for the given continued proportion. So I'll give you one question, you try to solve it. Okay? So that is the first question. I'm giving you another question. And
Don't
okay, use the condition B square is equal to AC, and please send your answer to the chat. The second question, even this is given that this is a continuous proportion. Okay, so you need to find 2 is to dash is to 30. I'll give you 1 minute time. We know that product of, if you're not comfortable with B square is equal to AC, it's okay. You just can write wherever the number is not there, write X. We know that product of means is equal to product of X. So write it down. Product of means is equal to product of X. Okay. So what is the product of mean? X into X. Product of mean is X into X. And extreme is 2 into 30. Maggie, are you listening, Maggie?
Yeah, CP.
Tell me, Maggie, what is X into X?
64.
So X into X is X square. 2 into 32 is 64. Now we have to think of a number whose square is 64. Right? Which number, if you square, will you get 64? What is 6 into 6? What is 6 into 6?
46.
36.
46.
7 into 7?
49. 49.
Into 8?
8. 64.
So, the number which we want is 8. So, if I raise 8 to the power of 2, then we get 64. That means the required X is 8. Then the required proportion is going to be 2 is to 8 is proportional to 8 is to 64.
What if it is a ratio with 3 numbers?
3 numbers. So generally,
Yes.
have a ratio with 3 numbers. Sometimes a good question. Sometimes you might have a ratio.
I got it.
Then what will be the means and extremes in that?
Yeah, I'll tell you. So mostly what happens is we represent continued proportion with the ratio of three numbers. Say our continued proportion is 1:2:2:4. Okay? If this is a proportion,
Yeah.
this can be represented as 1:2:4. So this is another representation for continued.
Uh-huh.
The thing we had done like that day you had
Oh.
done that sibling
A
ka
is to
thing.
B is to C.
The
We can represent continued proportion like this. Now what is it B? What did you say?
Akka, like last week we had done that thing, the sibling thing, and there's chocolates and there's 1,000 rupees, and then one person is competing with.
Expenditure and all that.
Correct. That was actually a continued proportion. Correct. Good. Okay. So we have frog. Okay. The frog jumps to the adjacent box. That means it can go up or it can come down. It can go to the side. It can go to the left. Where it cannot go, it cannot like this. It cannot travel diagonally. It cannot travel diagonally in this case. It cannot travel diagonally in this case. It cannot travel diagonally in this case. So it has only four options. It can go up, down, or either side. But if you see for frog like in this spaces, it can only go to it can only go this side or this side. It can't travel, right? So the question is, at a particular point, every frog jumps. Okay, so every frog gets to jump. That means not even one frog is staying in the original place where it's there. So every frog jumps at the same time. So then what is the minimum number of MP? So
All the frogs have to jump in the same direction.
no, they don't. I mean, they could jump in any direction. Direction doesn't matter here. But every frog jumps to the adjacent one. So, what is a perfect combination so that the frogs jump and we get maximum number of empty boxes? So, this is the puzzle.
124.
Yeah, you say 24, but let's see. It could be reduced a bit also. Okay, so what I'm going to tell is not the final answer. I'm just trying to think. Let's think together. So let's pick up this particular box. Okay, let's say this frog is coming here, this frog is coming here, this frog is coming here, and this frog is coming here. All these four frogs can come here because this can go to the left, this can go towards the right, this can come down, and this can go up.
But more than one frog in one box.
Yeah, that could be the case. They all can come to the same box also.
That wasn't mentioned. I thought only one box for one frog.
No, it's not like that. In a box, you can even fit 25 frogs also if that is the case. But
That's not possible.
yes,
I never knew this.
it's okay.
Nikhil?
So, would you like to have one more day to think about this?
Yes, please.
Okay, then one more day. So, this is the basic idea. So, if I'm picking this, all these four frogs can come here, but this frog has to go up. So, this can come down. So, these two frogs can come to this. So, what happened? We have cleared out 1, 2, 3, 4, 5, 6, 7 boxes to just 2 boxes. So, all these 4 come here, all these 3 come here. Okay. So, in a way, we have reduced 7 boxes to just 2 boxes.
This is the famous actor.
What is it?
Someone is watching something.
Somebody was watching a video.
It's okay. What?
No, that was my brother unmuting and shouting.
Okay, fine. Okay, so I hope you all understood what is the possibility here. So I'll give you one more day time to think about this puzzle and get back to me with the answer.